All right. It is 1 after, so I'm going to go ahead and get started with today's live code review. So Jonathan has graciously agreed to let me do a live code review of his solution to the command line to-do list. It's a very thorough solution, so it should be fun to dig through. I suppose it might be helpful. Let's see here. This is a public repo, so I'm going to share this URL in the chat room in case anybody wants to follow along at home or dig closer into this. I think you should be able to just click on that link and it'll take you to the web interface. Yep. Cool. And Jonathan's got like a very thorough README in there too, which is super helpful. So let's get going. Where to start in a new code base? There's a lot of stuff in here. There's a README, tasks.js, which looks like our entry point. But a lot of times where I'll start in a new code base is the tests, especially for something like this. Because the tests, if they're written well, have this great feature in which they kind of explain to you exactly how the code is supposed to behave. And so a good test can actually serve as a good documentation, kind of orientation for what's going on. So let's take a look at this. So we're importing some expect from chai and this exec sync thing from child process. And we got 2 contexts in this test file here. It looks like we got context for invalid arguments down here and one for valid arguments. So it looks like kind of broken up the test cases between like happy path and unhappy path. And then looks like we're using exec sync here to actually execute commands in the shell and then get the output of those commands as a string in this response variable. And then we're sort of asserting that the right thing was printed out by the command. So this is a little bit of a tricky assignment, right? Because you're writing a command line app and then you have to test it somehow. And this is probably, there's a couple ways you could approach testing to this. And this using exec sync here to just basically have your tests run commands in the shell and then read the output is going to be the most kind of thorough way to test it in one sense, because you're interacting with it exactly the way a user would interact with it. If this were like a web application, this would be the equivalent of writing a script that actually like goes to the web page and clicks on things and then looks at the HTML that's loaded and makes sure that it's the right thing. So this is a really good way to do an end-to-end test for this type of application. And so we can see here that we've got the task add command, and we're expecting a response. We're using regular expressions here to test for that the right thing got returned, right? It should be created task, some number, and we're testing that regular expression against the response that gets back. So there's a few tests in here like this. And it looks like the first test, we're actually adding a task, and then we're sort of parsing out the ID from the output, and then saving it in this sort of like file global variable, this ID. And then it gets used in the next test where we go and like test deleting a response or completing a item in the task list. And then it's the same kind of thing, check that the response has the right text in it, completed the task, and then we're pulling the ID again. Similar task for list and for help. So So overall, like the way these tests are laid out is nice. The formatting's nice. It's kind of easy to come through here and read. And I like the use of context blocks to sort of group the tests logically. Here they're grouped with like, tests for the happy path where valid arguments are used versus tests down here at the bottom. It looks like where invalid arguments get passed in. So like, invalid task ID and that sort of thing. Another way you could group these is by actions. You could have like all of the tests for add together in a context and all of the tests for done in a context. And you can really do that either way, but it's nice to sort of group them logically. So kudos for that. A couple things that jump out in here though are, I think actually this expect syntax is, so this is working, right? Expect, and then we're doing this, this expression here, create a regular expression, call test on it, and then check if it's true or false. That works, but expect actually gives us some nicer ways to do this. So let me just run the tests over here in this other window, and I can show you what I'm talking about. So there's the tests all running and passing. You'll notice there's like red output here under the milliseconds, and that's because these tests each take about over 100 milliseconds to run. And Mocha sort of tries to give you a hint on like, oh, these tests seem like they're taking longer than they should be. And the reason they're taking a little longer is because it just takes a second for the operating system to start up a brand new process. And each of these tests is doing that with this exec sync. So it's sort of expected that sort of end-to-end test would be a little slower, but that's why you're getting that sort of scary red milliseconds reminder there. Okay, anyway, so expect syntax. So there's a couple different ways we could rewrite this test that would make it easier to read with things that Chai gives us. So we can say expect, instead of saying expect true, we can say expect the, expectation to be true. It's the same thing, but it just reads a little bit more like English. And can be a little easier to parse. The other cool thing is that Chai actually provides specific tests for testing regular expression matches. So you can actually say expect response to match and then give it a regular expression. And that's probably the most readable way that you could do this in Chai. And of course I did it wrong, so it's failing. Command was unsuccessful due to a format error. Response replace. Anybody see what I'm doing wrong?
Spelling of match.
Match, yeah.
And math, response, thank you.
And response as well.
Response as well. I only spelled two things and I spelled them both wrong. Thank you. Response. Typing in front of people is so hard.
Response is still spelled wrong.
That's awesome. RESPONSE. Response. Does that look good? Before I run this again and embarrass myself. Yay! Okay. So that would be my feedback for this test, is that like just that there's better expect matchers that you can use that will make the test a little bit more readable. You get similar things going on down here with this matcher. And making the thing more readable it's helpful for you when you come back later. It's also helpful as you're writing code. The more readable, the more like clear it is, the easier it's going to be for you to find bugs in your own code as you're writing it. And line 34 is a really good example of this. If you actually add some white space here, I think we'll see that these parentheses are not lined up the way you'd want. So we have like expect, and then the matching print is here, and then there's nothing after it. And this dot true is hanging off of this test response. And I think this dot true is actually supposed to be down here. So you've actually got a case there where I think there was a bug in that test. And let's see if we run the test again now. Right, so the test fails because this regular expression isn't matching for some reason. So the case where you had like a bug in your test that was making the test pass when it shouldn't have, or possibly there's a couple bugs in this test, and like now that the expectation statement is right, the like regular expression needs to be debugged. Maybe it's not quite matching what it wants to be matching. But anyway, this same regular expression thing we could do with the match, the expect something to match syntax with chai expect. Cool, so let's go look at some code. We got basic sense of the test file. So let's go look at the task, which is where we came into this thing. So this is sort of the top level module. We've got kind of a description of what's going on up here in a comment. We're importing commands from files in the commands directory, importing some messages, and let's kind of scroll down here. There we're getting the args from the process argv list. So that's getting us our slice two. So that's getting us all of the arguments after the like node tasks part. So all the, like the user supplied arguments. And so let's see. So we're checking if there was a command defined, and then we're checking for if it was help. Print out the help message. Then it looks like we've got, I'm going to split this open here to source messages. Let's look at that. So we've got a messages file here that's sort of mapping some keywords to like full text. So it looks like this is being used as sort of like a cheap way to do views almost, where you have like these canned responses, and some of them looks like even have like placeholders. So it's like a really lightweight templating thing that we're implementing here. And that's kind of nice. You don't have to have the full text of the help message here, and it makes that like a little bit more reusable. So that's kind of a nice feature. It keeps the code cleaner. So then we get this big if-else statement that's just parsing the command line args, it looks like. Checking for the add command and making sure that it's got the right number of parameters to it. And then it calls the add function. It looks like the add function is being handed the file to look in and the name of the task, and then a callback, this result action callback, which that was defined up here, wasn't it? Which looks like it just logs out the result. Same thing here for done. And looks like we're doing a lot of validation of the arguments and then calling the done. And then there's sort of an else here at the bottom for if none of the commands matched, if none of the validation passed for any of the commands, then you'll get like this failure message. What's interesting to me, looking at this now, is that we've got like these nested if-else statements, which can start to get a little complicated. And I'm kind of wondering, the final else of this inner else statement, does this result action messages command fail? And so does the outer else. So I think there might be a way that these two if statements could be combined. Because they're all, I don't know that you have like two, you could just have like if args is undefined, you could check that first and then like print out the error message and then go on to the other else ifs. So you might be able to collapse those two if statements is what I'm saying there, which would get rid of some of this nesting, which might make this a little easier to follow. Sometimes like long if else blocks that are nested inside of other if else blocks, it looks like we're actually going 3 if else's deep here. This is an if in an else if in an if. And sometimes it can get hard to follow when it ends up being this long. So there you might look for ways to clean this up or like flatten it so it's not as nested. But let's go look at some of the commands. do so commands and add. So pull in file systems and those messages again. And then we're exporting this function that takes the file name and adds on the right path and the right extension. And then calls read file with the callback. And we've got this result action on the error, else. Let's see, we parse the data in the data file and we get a list object. And then we are, so this is probably a point where it'd be good to look at that data file. Is that right? I'm gonna check this out again and then. Uh-oh. Nope. Data test.json. 056. Something about that seems wrong. I'm sorry. I think I've changed some of these files. Get on. Nope. Okay. All right. So we've got this data file that has an object in it. So this is what it starts like when we just check out the repo. It's an object and it has a 0 attribute that points to, oh, hang on a second. Is that right? No. Okay. Yeah, so it is an object with a 0 attribute that points to the number 56, which I think is storing, from looking at this earlier, I kind of determined this. So that's storing like the ID, like the next ID to use. So presumably that started at 1 at one point and like tasks were added and removed and added and removed. And since the data file was like checked in with the repository, I think we're seeing this file like sort of in a later state.
Yeah, it should have been 1.
Gotcha. So we're grabbing that list object 0, which is like the next ID, adding 1 to it, and then assigning the item text, which is just our item text. Where does that come from? Did I miss something? Ah, right. Item text. It's what's got called, right? It got passed into the add function. Make this bigger. There it is. So we're sticking it in the object with a numeric key. And then it looks like we're just writing that object back into the file and handling errors by calling the callback with the right message. Otherwise, we call the callback with a success message, and looks like we're doing a replace on the message to actually put in the number of the ID that we added in here. So, so let's see, a few things in here. So one is using 0 to like keep track of the ID. Like 0 is just not a very descriptive thing to call the highest ID we've used so far. Object keys can be anything you want, so we could store that in like a named key that might be a little more descriptive, like index or highest task number or something like that. And any chance you have to like make variables more descriptive, more specific, this is going to help people come in and follow the code better, including yourself later on down the line. So that might be one suggestion I have, is like, don't store that don't use 0 as the key, use something a little more descriptive. The other thing you could consider doing is, instead of storing the tasks in an object that has like numbers as keys, you could just store them in an array in the JSON file. And then you would always be able to just say array.length to get that, like, what's the next index. You could solve the problem that way. The problem with doing the array that way is that you'll end up reusing IDs, which may or may not be the way you want to do it, right? So as the array gets shorter, then when there's 8 elements in the array, the next thing you add will always be 9. And if you delete 9 and then add a new task, you'll get another 9, right? It'll go from 8 to 9 again. Doing it this way in the object, you sort of have this persistent. So we saw, like, when we loaded this thing, our next ID was going to be 57, even though the first 56 tasks had been deleted at some point previously. I guess it depends on like which kind of behavior you want. If you want a task ID to be like used once and only once ever, even after that task is deleted, then storing it in an object like this might make more sense, I guess. Let's see, other things. So we also have a lot of nesting in this file. Again, you've got, and this is a little bit of the nature of callbacks, right? You've got read file that gets past a callback, and then there's an if block in that, and then an else, and then that gets indented. And then there's this other write file, and that's got a callback, and that callback has some if. So you end up getting a lot of this little white space. And sometimes you hear people talking about a spaceship. Your code starts to it's sort of kind of launching from the left side of the page and like getting pushed further and further out. And all of that can just kind of make things a little harder to follow. And there are a couple of tricks you can use to reduce some of that. One is when you have a case like this where your function is basically an if and then an else and nothing else, and you're checking some like error condition at the beginning, one thing you can do is take the if and then just return in your if statement. So if you're checking for some error and you've got an error, you can just say, you know, do whatever you're going to do and then return. Or even, you could even do this. If you can spell return right, which apparently I can't, there we go. And that allows you to take out this else. I'm gonna have to find the right closing parenthesis. There it is. So it allows us to sort of outdent all of that code, right? Because we're just short-circuiting the circuit here. We're saying, okay, if we've got an error, then return. And then you just move on. You don't need an else block, and you don't have to push all that code out. And you could do that same thing up here, right? Just say return if there's a condition. Otherwise, just do the body of the code. So that already starts to, like, the code's shorter. It's less indented. It's a little less complicated. And then the other thing you could do with these sort of nested callbacks is actually like declare these callback functions somewhere else and just name them, or like, actually I think a better way to say that is you could take this, let me think about this. So you could look inside this callback here, for instance, and let's see, what is this actually using? It is, the only thing it's really taking is the list object here from like the context around it. So you might be able to take this whole function, right, and copy it down here and just call it something, right? And this could be, we create a function here called,
Just know,
what file are we in?
well, just know this, okay?
Handle.
Next week I'm gonna be in Fairfax, Washington, Fairfax, Virginia.
And
We're putting together the proposal,
list object.
okay? All right.
And then call this
pricing
the
reference to that is gonna be
new
similar to
ID.
what we currently have with KBR Raleigh right now. Okay, we got profits on that.
So you could create a function that returns this callback function for you, just kind of builds it and returns it. and then take this thing here.
Less than 2 weeks
Call
because
that new,
here's the reason for that.
call that new ID,
The proposal
and
the
then
pricing
stick it
next week,
here.
24th, it's got to be submitted to the government. So that means
Sorry, did that wrong.
everything's in black and white
Handle
in
success.
2 weeks.
New ID.
Okay. Then.
And that sort of
Yeah,
breaks up your
Just
breaks
let
up
me
your
know.
code a little bit more. You've got
I would need to know if we're
instead of having like nest things further and further and further, you can sort of like pull out some of those callback functions and give them a name, or at least create like a generator method. So this handle success function is actually returning a function.
Right.
And so you're sort of building the appropriate callback function based on like whatever the new ID is. So there's a couple different routes you can go to sort of take a giant function that has a lot of like nested callbacks and nested if blocks and start to break it up into pieces and reduce some of that indentation and the amount of code the reader has to understand all at once. When there's a lot of like deep indentation like that, at any point you sort of have to really be keeping track of like how many levels in am I and where do the curly braces match up, and it can get a little just cognitively harder to follow. I'm going to just revert this file to extract out though. So we're looking at the right thing. Okay, cool. So what are we on time? 1:28. Let's go look at one of these other ones. So list should be interesting. So list is using this thing called CLI table. That sounds exciting. And same kind of thing. It's exporting a function.
You also see
it's pulling in the
rates,
base file and like building the relative path to the file where things are stored. It's reading in that data, checking for an error, parsing the JSON. And then it's building this table object from that library that got imported.
Okay, armed security guards, I want to make sure that
with a couple of messages from the messages file. Let's go see what those look like. Source messages. So what is list column head? Okay, so it's ID and description. And then we're getting some items. So we're getting a list object, and we're pulling out all the keys. And then we're slicing, so we're getting all but the first key, which probably is a way to avoid getting that like key that holds the index. And then we're mapping all of those keys and parsing them as integers. So I guess they're numeric keys. And then, let's see, we're sorting them. And then for each one, we're pushing something onto this table object, which apparently can be pushed onto like an array with the value and then the current value. The value, sorry, so current value is the current ID, and then list object current value is the value for that ID from the list object. So we're pushing all this stuff onto the table, and then we're saying table toString and printing all that out in the result, along with this ternary in here checking for if there's only one item, then print list sum report 1, which says 1 task. Otherwise, print list sum report 2, which is some number, and then tasks. Gotcha. Cool. I want to see what this looks like because it sounds fun. Node tasks. So if we add a couple of tasks, bacon, and then we list. Oh, see, that's really nice. So you have like a nice tabulated output. It looks like this tasks library is sort of doing all the formatting for you. So that's really cool. So comments on this file. have some of the same sort of like nesting issues going on here. One other thing that jumps out at me is this thing here. Like when I got to this was hard for me to follow exactly. It's a little bit of a kind of a, you've got like ternary expression, which can be, you know, this like question mark with the colon. I don't have anything against ternaries, but this starts to get a little complicated when like the second part of the ternary is actually like a multi-line formatted method call. And this is all sort of embedded inside like this list of things that are being concatenated to each other inside another function call. There's a lot going on. It's like a really dense piece of code. And so it might be helpful. The thing this is building is this like 3 tasks line here at the bottom. And so maybe what we want to do is just create another variable for that and just call it footer. And then take this thing and move it like that. So now we've separated that logic a little bit. This should be a little easier to read. So now it's easy to see here that this result action is being passed called with a table and a new line and a footer. So suddenly line 66 gets like way easier to follow. And then up here in the footer, we know, okay, we're just building a footer here. And then you could do a little bit of formatting here to maybe make this a little easier to read with ternaries. I like to put the condition on one line and then put the 2 options kind of on lines by themselves. And now that we're not in the context of that other call, we can get rid of some of those parens. So this probably, to my eyes, is like a little easier to follow, right? So I've got a footer. Is there one item? Then do the list sum report 1, otherwise do list sum report 2. The other thing that might be going on here is that this like messages idiom where we've got like these strings and other files, while that's helpful for those like long error messages, it may be making this more complicated than it needs to be because list sum report 1, this is just one task is that string. And this one here is just like item IDs, length, space, tasks dot period. So you could simplify this a little bit more just by saying tasks period, just inlining this stuff. I'm not sure that the messages in this case give you enough benefit to warrant sort of the complexity that they add. See, this just gets like a lot easier to read. It's a lot simpler. There's a lot less going on. Kind of easier to follow. It might even work. I don't know. It works.
But as the README file says, one of the motivations for this design was to make it internationalizable so that all those messages are in a block labeled messages in English. So you could have other blocks with messages in other languages and then choose your language. And as soon as you start putting any text into the code, then I think you're interfering with that goal, if you have that goal.
That is absolutely correct. Yeah, if one of your requirements for this application is that it works in multiple languages, then yeah, suddenly this kind of stuff does not work anymore. So yeah, if that's one of your requirements, you definitely have to go the more complicated route. So that's entirely valid. Yeah. So yeah, and since this is sort of a contrived example application, yeah, you can sort of kind of pick what you want your constraints to be, right? So yeah, if you're going for internationalization, then having these hard-coded strings is going to be a problem for you, for sure. And that is something you want to keep in mind if you're working at a company that's running a website that needs to cater to multiple languages or something like that. Often in my experience, it's easy to start adding complexity, anticipating like scaling problems you may never hit, if that makes sense. So it's something to watch out for. I've been places where like a lot of work has been put into like, oh, we're going to make this, you know, able to be internationalized whenever we get to that problem. And then like the company actually never makes it long enough to have the problem of like customers in other countries or customers that speak multiple languages. So yeah. Anyway, but that's definitely a valid concern a lot of time, and it is something to keep an eye out for. So what else in here? So this thing sticks out at me here, this sort, and then you're passing it a sorting function that just compares A and B. I think that's the default behavior of sort, unless there's something about the sort order, but I think if we just call sort, I think that works the same way. So this sort of, this behavior where, you know, A minus B, which is basically mimicking the sort of default behavior of sort. So I think you can just remove that.
I think you're right if they all have the same number of digits. But I believe that if they're heterogeneous in digit length, then it's actually a string sort is default, isn't that right? And therefore they wouldn't be.
It's a string sort if there's strings. Are the things you're sorting here strings? Because you're parsing them into integers here.
Oh, so you're saying once they are numeric, once they're numbers, then the default is to sort them.
That's yeah, that's correct. It's gonna do a comparison. So yeah, let's test that out. So if I have numbers sort, yeah, it's just by default it'll sort them. And if we add some heterogeneous things in here, we can make sure this still works. But yeah, sort will sort numbers numerically if you have an array of numbers. No, it won't. What just happened? Oh my goodness. Wow. Okay. That is new to me. That is very new to me. This is why I love code review. I learn something every day. Wow, that's a little terrifying. So if you have an array of numbers and you call sort on it, it sorts them alphabetically. I have no response to that. Wow, okay. Pro tip, folks. Wow, okay. That's really, really terrifying. I'm sorry. I'm wondering how often that bug has bit me and I didn't even know it. Goodness gracious. All right, so leave that in there. That is important. Cool. So the other thing in here, so this object.keys slice. So this is a clever way to get all the keys except the one that's 0. But I have a feeling that we're just getting lucky here. That object.keys, so this slice is assuming that these keys are going to come out of this keys method in a certain order and that this key 0 is always going to be first. But you're not explicitly sorting these keys before you're slicing. And I don't know, I'm going to go check the documentation. But usually this kind of a keys method on an object, at least in other languages, doesn't make any promises about the order that the keys are coming back in. I'm going to see if JavaScript makes some promise about that I'm not aware of. Object.keys returns an array whose elements are strings corresponding to the enumerable properties found upon the object. The ordering of the properties is the same as that given by looping over the properties of the object manually. Yeah, but I don't know. You could potentially start to get into trouble assuming they're going to be sorted numerically, especially since, as we've seen, even if they're just sorted as strings, you'll get into trouble if you have like multiple IDs. 0 will probably always be first in that case, but
I think it said, doesn't it say that it's in the same order as for in? And the for in documentation says it's in original insertion order.
Gotcha. Yeah, that would make sense. In original insertion order, which is a little bit undefined, right? So what order are the keys inserted if you just inflate, if you like parse that data from a JSON string? So it's probably like lexically the way they're in there. It's a little bit undefined, and you could, I think it's probably a little bit of a leap of faith to assume that they're always going to come out in sorted order. So it may be safer in this case to just do the sorting. The other thing you could do is just explicitly pull out the one you don't want, right? So you could just delete list object 0, right? You just pull that one out first. Or make a copy of the list object that has everything but that one in it. Or sort them, or filter it out, right? So the other thing you could do here is, instead of saying slice, you could say filter, and just get the one where the key is not equal to 0. And that might just be a little bit safer. And also maybe a little bit clearer, like what's going on to the reader. But yeah, the slice kind of looks like something like, oh, that works, but it seems a little bit coincidental that it's working, and might be a little bit of a hack. All right, so commands, list. We saw list. We're in list. We saw add. Let's look at done. Done's probably going to be very similar. File exists. I don't want to create the file. I want to read the file. There we go. Yeah, so by now this structure is looking really familiar. We are creating a removed array and then going through the items. So it looks like done here is allowing us to check off like multiple things at once. So we're looping through, and we are, right, we're looping through the item IDs. These are the item IDs to be deleted. And then we're sort of adding them to this list object. We're deleting from the list object, and we're pushing the strings. We're pushing the thing we deleted onto this removed thing, probably so that we can print it out later. Yeah, so for each item that was removed, we sort of print out like this is the thing that was removed. That makes sense. Let's see what that looks like in here. Let's see, so if I list these, I get these back, and then if I say done 56, yeah, prints it out. So that's nice. Curio. So some of the comments the other files apply here, just about like maybe trying to reduce some of the deep nesting of callbacks here and if statements. This is probably like a minor preference thing, but usually if I'm looping through a list of things, item is less than item IDs 1. Oh, I see. You're looping through from the start to the finish. So how does this work, Jonathan? Is it can you give it a range of IDs? Is that the idea?
Yeah, you give it a hyphen delimited range.
Gotcha. And so item IDs, this item IDs that's getting passed in is like a 2-element.
It's 1 or 2. It can have just a number, or it can have 2 numbers with a hyphen in between.
Gotcha. But by the time it gets passed into this done thing here, it's an array that has either 0 or 1 elements in it, or it always has 2 elements coming into here.
I think it always has 2, because if it's only 1 number, then the number is duplicated.
Gotcha. I see that happening here. Okay. So, right. So we're splitting on the hyphen, and then we're checking to see, is there just one item ID? And if there is, then, so this is like a start and an end, this item IDs that gets passed in.
Right.
So it's really sort of like a start and end of a range. Mhm. So one thing you might think about doing is, instead of representing that start and end of the range as an array with two values, it could be a little easier to follow if item IDs was like an object that had a start and an end, or some sort of named keys. And that way, when you get into this code, it would be a little clearer item IDs, just because there's a lot of item IDs floating around here. There's like all the IDs in your to-do list, and these are specifically the item IDs. And these aren't even the item IDs that you want to delete. These are the start and ending of the range of item IDs you want to delete. So there's just a lot of things that in this context item IDs could mean. And so it might help this read a little bit better if at some point item IDs 0 got, either you pass it as an object, so you can say item IDs start, right, and end. So something like that would maybe like be a little bit easier to follow. Or you could even just like, I don't know if you've got ES6 turned on here, but you could even just destructure this in the call here. And use destructuring to just take that array and, like, in the function statement here, just like pull out the first and second elements this way. Might be range, range, start, and end, or something like that. So two other things I want to call out just in general about this code. Well, there's a few things. One is there's a lot of error handling in here, and like checking to see, like, did this go wrong? Did that go wrong? And you obviously thought about things like internationalization, and what if it's, we're going to need to do this in Spanish or French or Klingon or whatever. So it's a very thorough implementation of this project. A lot of thought put into it, which is really nice to see. There's so there's a lot of thought put into the, like, what are all the different cases we need to handle? What are the error conditions? How do we want to handle those error conditions? I kind of like the fact that you're passing in a callback to these done and add and list commands, so that they don't have to know necessarily what's to be done with result messages. They just sort of return the result messages. And that's kind of nice because it decouples each of these commands from the command line, and you could call each of these commands from a web interface or anything else, which is neat. So I like that decoupling. But I think there are a couple of like easy refactorings that would be a really big win here that we haven't talked about already. And one is just this block of code here, read file, really starting here all the way down to about here. That block of code appears in all three of these files. And I think the only difference is what the error message is that's going to be returned on a failure. But otherwise, the first thing you always do is, you read in the file, and then you parse the JSON, and then you move on to like doing whatever it is you're going to do with it. And then in add and delete, this chunk of code is pretty much the same, again, except for the specific error message. And so you could sort of further simplify this code and kind of modularize it by maybe pulling out the reading and the writing bits of this into another file that just handles, like, read the tasks, write the tasks. And you could just create some functions that have this sort of write tasks, or have these operating a little bit higher level of abstraction where you just pass them a task list, and it saves it, and it takes care of knowing, how those are going to be persisted and converting them to JSON, writing them into the right file, all of that thing. And then you can have sort of a partner method, load tasks, right, that just pulls them out. And then this code could get a little bit simpler, right? And this like file path information could all get pushed down into those modules as well. So that in the end, you just have to call load tasks, and then error tasks. You have this sort of thing going on. It sort of helps you get rid of a lot of this code here. And you could assume that the task list, if you get it back, it's already been parsed. You don't have to do the JSON parsing. So all of that might help simplify some of that code. And then it helps you out later when you go back in and if you ever need to change the way that the objects are being serialized to disk, or whether you're writing to a file or not, or you want to move it onto a database or into the cloud or anything like that. You've sort of isolated all of your like input, output, your IO functions, and abstracted those so that logic's not sort of duplicated everywhere. And the other thing I wanted to talk about was comments. So there's a lot of comments in these files, which I think is, it can be a really good practice as you're learning and you're sort of writing through code and like leaving notes for yourself. Like, this is what this is doing. This is what that's doing. But a lot of these files have almost as many comments as they do lines of code. And often the comments are just restating what the code is saying. So I have a line here that says import the add function from the add module. And then the line, module require add. Some of these things are common enough, straightforward enough JavaScript that the code should really speak for itself. If someone coming into this code doesn't understand that line 8 is importing the add function from the add module, they're probably not going to get the rest of this either. And so like adding the comment probably isn't worth the space it's taking up. And these files would be a lot shorter if there were fewer comments, and shorter files aren't always an end into themselves, but it does make it easier to scan through code if it fits in one screen. So the more code gets sort of pushed out artificially, it can get a little hard to follow. You're scrolling around more. So a lot of these comments, like if it was help, and args0 equals help, kind of states that pretty well. A lot of these things can probably go away. And code might be a little bit better for it. There's some of these complicated if expressions here. So here you've got a Boolean expression with 5 parts, I think. And that is the kind of thing that like just sitting here by itself, a comment just sort of reminding people that like, oh, this is just making sure they're both valid, is useful. But I would say even in that case, you can probably get rid of the comment by replacing this block with either a function that you just pass in the item IDs and then it returns true or false, whether they're valid. And then if you give the function a good name, like item IDs are valid, then your thing looks like item IDs are valid. You could replace this if statement with just a call to a function like that. And then you don't really need the comment. And this sort of reads pretty easily, like if item IDs are valid, these item IDs, then do the following. And so there are ways you can sort of make the code speak more for itself that require fewer comments. Keep undoing, Trevor. No, I've lost it. It's right here, I think. There are ways you can make the code more readable by like breaking things out into well-named functions or adding a few more well-named variables and removing some of these comments. And the nice thing about readable code is that comments can tend to get stale. So with all these comments here, it'd be really easy to come in and I might add a condition to this if block that checks for something else. And if I'm coming in here and doing this, I may not remember to look up 6 lines above where I am to see that like, oh, there's a comment being made about this if expression, and I've just changed the meaning of this expression. So now it's not just checking that they're both valid, it's checking that they're both valid, you know, and some other thing. And it's really easy to forget to come back and update that comment. And so now I have like some other thing happening down here. But a reader of this code is going to come in and say, oh, this is just checking to make sure these things are valid. And so now the comment is sort of lying about the code, which can cause a lot of confusion when people are coming in to read it. It's also the other thing that can happen is comments can sort of drift from the code that they refer to. You know, as we start to add stuff like at the top of this ternary, now this comment is true, but it's true about things that are actually several lines below where it's actually listed. The comment should have been moved down at some point. And this is something you definitely see in older code bases. You'll find comments and a lot of the time they're wrong or they're in the wrong place. It's hard to trust them. So they can end up causing a lot more trouble than they're worth. And you're probably better off, like if you know, a lot of times you just don't need the comment and you can delete it. And if you get in a case where you feel like, yeah, I feel like I need to put a comment here because this is a little hard to follow. If it is hard to follow, then like ask yourself, how can I rewrite the code so it's not hard to follow so that I don't have to like add a comment to explain it? Can I make the code speak for itself? And often you're going to be able to find a way to do that. The times where you're not going to be able to find a way to do that are when the code is doing something that's just counterintuitive. And a lot of times that has to do with like business logic. So sometimes, you know, you may have, you know, there's some special sale and some marketing department executive said, hey, we're going to give everybody whose name is Mary a 5% discount on Mother's Day or whatever. It's just some like weird arbitrary rule. And so you end up with code somewhere that's checking if the first name is Mary and then reducing the price based on that. And that kind of thing, no matter how well you write that code, it's going to be confusing because it doesn't make intuitive sense. And so sometimes you will need a comment in there just to sort of call out that like, yes, I know this is weird. We're doing it on purpose because, you know, April Scholzbacher in marketing told us to or whatever. So sometimes those kind of comments can be helpful if it's like explaining the reasoning behind sort of the why of logic. But if you have to have comments just to explain like what the code is doing, then it could probably be refactored. So that's my rant on comments. But yeah, I really appreciate you, Jonathan, letting us walk through your code today. Lots of interesting stuff to look at in here. And I posted the link in the chat earlier for the rest of y'all. So you know, dig through Jonathan's code. There's a lot of fun stuff in there. And a fun exercise might be to go through and do like some of the refactorings I suggested and see if you can get a handle on that. That would be really good practice. Like coming into a code base that's not yours and then like making changes to it. It's a really good skill to develop. So that might be a fun extra credit thing if you've already worked on this challenge, or even if you haven't before, like try coming into this code base and then like making some of the refactoring changes I suggested or others that you might see. And see what it feels like to like come into an existing code base and like, you know, add features or improve things. Cool. All right, everybody. Well, my time is up. So appreciate you showing up for a live code review on Friday. Happy Friday, everybody. And I will see you in the chat rooms.